Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve the problem number 1346. Check if n and its double exist. Given an array ARR of integers, check if there exist two integers I and j such that I is not equal to j. First condition, 0 is less than I, comma, j is less than array dot length. So it is inside the array. ARR of I is equal to 2 into ARR of j. So it's stating that we have to return true if there exist two indices I and j where this I and j is not in the same position. This is the first condition. Then second condition is lying inside that array, and third condition is the ith element should be double of that jth element. For example, if the ARR of I is 10, then AR of j should be 5, like that. But still if check whether if realize that in array we have 102, there exists a 0 into 2 is 0, and if I and j are at same position, it returns true, right? That's why they have given I is not equal to j. If you don't understand this, we shall see in approaches. Wait. So take this example, 10, 2, 5, 3. 10 to 5, 3. 10 to 5, 3. Fine. Now either there is a element and its double exists, yes. 5 and its double exist. Right? So we return true. This is the first example. Let us see the second example. It is 31711. It is false because there don't exist any number with its double inside that array. Now that's all. So how to approach this problem? First approach is, if I can iterate over every elements. Take for example the same from here I will iterate through every element except this element and check whether there is any double exist. What is double of 10? It is 20. If there is any 20 exists in this array, no. Now take this element and check whether there exists any double of 2. There is any double of 2? No, there is no 4. Now take this 5 and check whether there exists any double of 2 except this 5. Yes, 10 exists. So put, because 2 into 5 is equal to 10. So return true. So this is my first approach. This is my brute force approach. What is my time and space complexity? My time complexity is O of n square, because I am fixing one element and checking for whole array, then fixing another element and checking for whole array. So first for n elements I will check for n elements, right? So for one element I check for whole array. So it is n square and space complexity will be O of 1. Right? This is my first approach. What is my second approach? How to optimize it? We are just finding whether a number and its double are there in an array. So to find efficiently, can we use set? How to use it? Just push everything into this set. For example, 10, 2, 5 and 3 are in this set. Now iterate to this array. First it will be standing at 10. Whether 20 is in this set? No. Whether this 2 in this set? No. Sorry, 2 into 2, 4 in this set? No. Whether this 5 into 2 is 10 in this set? Yes. We have 10 in this set. So return true. So this is slightly optimal approach. And what is the time complexity? In worst case, it goes up to n log n, because we are traversing to every elements in the array and also checking whether it exists in set or not. So it is n log n. What is space complexity? It is O of n, because we are using this sets data structure, right? In worst case, we have every elements are unique and we have n elements in the set, right? This is my second approach. Then what is my third approach? How can I still optimize that? If the array is sorted, if the array is sorted, can I use binary search? Can I use binary search to search for the double? That is, if the array is 2, 3, 5, 10, then first I choose this 2 and check for binary search of 4 in this whole array. This is my first step. Then in second step, I take this 3 and check whether there exists 6 by using binary search. Then I take this 5 and check whether 10 exists in this binary search, right? So this is my approach. Just a for loop. Inside that I am going to iterate with every elements in array. Then inside that I am going to do some binary search for 2 into I. If this returns true, then I will return true, right? If this for loop is completed without any return statement, I will return false, right? This is my approach too. So talking about the time complexity and space complexity. What is time complexity? Time complexity will be n log n, because we are using the sort of function which uses the merge sort. So what is the space? Space will be O of n at the worst time complexity, because we are using the merge sort, right? So the space will be O of n at the worst time complexity. So let me code it up. See here, it is an optimal approach. ARR.sort of for I in range of len of ARR, double is equal to ARR of I into 2. If it is 5, we store in double as 10. Then we are doing a binary search. See here, L is less than or equal to U, mid is equal to L plus U divided by 2. If ARR of mid is equal to double and I is not equal to mid, here this I is not equal to mid is so important, because if we don't put this I is not equal to mid, then I will show what will be happened, right? Then return true, right? If the mid element is greater than double, if for just for example, take the array as 1, 2, 5, 7, 10. Fine. Just take a 6 and 8. Now I am searching for something 2. Fine. If the mid element is at 6, the mid element is greater than the target. So where should I go to find this target? I should go to left off by eliminating this right off, right? That's why I have used here as U is equal to mid minus 1. Else L is equal to mid plus 1. We want to eliminate this left portion and go to right portion. Else I will return false, right? Let me submit it successfully. Now I will show what happens if we don't put this line. Yes, see here. This is my array. Minus 2, 0, 10, minus 19, 4, 6, minus 8. Is there exists any double? No, but still for this 0, double is also 0, and when the I and j are at that 0, it denotes that I find 0. So that's why I use this condition. Fine. Now let me code it as brute force. For brute force, we will do for every iteration. For I in range of len of ARR, then j in range of len of ARR. If I is not equal to j and ARR of I is equal to ARR of j into 2, then I will return true. right? Else, after finally I will return false. So this is my brute force. This is my brute force. Fine. This is my brute force. Now the set approach is, see here, I will declare a set now for I in ARR if this I into 2 exists in set, or this I divided by 2 exists in set, then I will return true, right? Then I will add I to set, return false, right? Let me run this. Fine. Now many of you ask some questions. Why do we need this? Why do we need this? I just take this. And we can see what output we are getting. Here it is passed. See here. Here it's failed. Here it is failed. Why? Because this 7 is inserted into the set at first, right? Now, while we are searching for 14 into 2, it is 28, but there exists 14 divided by 2, that is 7, right? That's why we will use here or I divided by 2 in set. Here there is no floor division. We don't convert into integer. We just keep as float because 6 divided by 2 is also 3, and 6 floor division 2, sorry, 7 floor division 2 is also 3, right? So that's the reason, because see here 6 floor division 2 is equal to 3, 7 floor division 2 is equal to 3. This is the reason why we don't use this floor division. Let me run with floor division. Just see here. 7 divided by 2 is 3 and 3 exists in set. So it returns true. So you should be careful when you using the operators too, right? Now let me submit this. So this is the third approach. We have totally 3 approach, and still we can also do this problem in hash table. You can try that hash table solution. If you don't know that, feel free to ask in comment section. I will also upload that in any other videos and update that video too. Okay, thank you.